Day 16 homework. There are some problems on here that are review problems from a previous unit, but there will be review problems on the test, so you need to make sure that you remember this stuff. So, what is the sum of the interior angles of a convex heptagon? First of all, you need to make sure you know all of the names of these shapes. So if you don't know what heptagon is, or hexagon, or pentagon, you need to go back and review that. But a heptagon has how many sides? Okay, a heptagon has 7 sides. So the sum of the interior angles, we used to do n minus 2 times 180. Okay, so for a heptagon, that's going to be 7 minus 2 times 180. So that is 900 degrees. Now, what is the sum of the exterior angles of a complex nonagon? Yeah, I'm going to go ahead and mention what a nonagon is, but it's not going to matter for this particular problem. A nonagon has 9 sides. However, the sum of the exterior angles is always 360, no matter how many sides it has. So the answer is going to be 360 degrees no matter what. Okay, let's look at problem number 3. All right, I've drawn this miscellaneous, not to scale quadrilateral to help me out. So I'm going to call this quadrilateral HELP. All right, so I don't know if this is going to turn out to be a kite or a parallelogram or a square or a rhombus or a rectangle or what. But in fact, maybe it would be helpful to write down the possibilities. So there are always 7 possibilities that we have to narrow down. And here they are. Either it's going to be a general parallelogram, okay, or it could be one of the 3 special parallelograms. Okay, it could be a rectangle, a rhombus, or a square. Okay, or, okay, so that's 4 things so far. Or it could be a kite, which is kind of its own thing. Or it could be one of the trapezoids. It could be a trapezoid, or it could be an isosceles trapezoid. Okay? So those are the 7 options. Okay, by the way, all 4 of these up here are parallelograms. These are just special kinds of parallelogram. So, let's break it down piece by piece and see what we've got. The most specific name, okay, so angle H is congruent to angle L. Okay, so that means angle H is congruent to angle L. Right there we've got opposite angles that are congruent. Opposite angles that are congruent. Does that eliminate anything? Maybe a trapezoid. Anyway, let's keep going. Angle P is congruent to angle E. Okay, so angle P is congruent to angle E. So we have both pairs of opposite angles congruent. All right, well that's one of the properties of a parallelogram. And in fact, it's one of the ways to prove that something's a parallelogram. So we've just eliminated these 3 possibilities. It It cannot be a trapezoid or a kite. It has to be either parallelogram or one of the special parallelograms. So we've got parallelogram so far. It's just a matter of, can we narrow it down further to a rectangle, a rhombus, or a square? So we have one more piece of information. pH is congruent to HE. Okay, so pH is congruent to HE. All right, so we have these consecutive sides that are congruent. All right, so since it's a parallelogram, that means opposite sides are congruent. So if this is a single mark, then, let me change colors. All right, if this is a single mark, then this will be a single mark. All right, because we already know it's a parallelogram, so that means we know that opposite sides will be congruent. If this is a single mark, then this should be the same, also a single mark. So basically we know that all four sides are congruent. Okay, so we have opposite angles congruent and we have all four sides congruent. So all four sides congruent is the definition for which one of these three special parallelograms. That's the definition of a rhombus. So we definitely know it's a rhombus now for sure. It's definitely a rhombus. Okay, so we can forget about rectangle because even if it has 90 degrees, that would make it a square. Do we have enough information? Do we know anything about it being 90 degrees? Do we know anything about the measures of the angles? No. So we have to stop at rhombus. We know it's a rhombus. You know, with more information, it could yet turn out to be a square, but with all the information we have, the best thing we can say about this, the most specific that we can prove, is that this is definitely a rhombus. Okay, so the answer to number 3 should be rhombus. Okay, so let's go back and do number 4. Okay, number 4. What is the most specific name we can prove for triangle STAR? So let's see, STAR. If M is the midpoint of segment SA and RT. Okay, so segment SA would be like this, and segment RT would be like this. All right, so we're talking about the diagonals here. Okay, so M is the midpoint of both segments. So if M is the midpoint, that means these two sides will equal to each other, and these sides will equal to each other. Okay, so in other words, the diagonals bisect each other. Diagonals bisect each other. Okay? Now, diagonals bisecting each other is one of the special properties of a parallelogram. In fact, it's one of the properties that proves that something is a parallelogram if the diagonals bisect each other. So that means we've just eliminated the kite and the trapezoid. So we're down to these 4 options. It's either a parallelogram or a special kind of parallelogram. But we have more information than that. SA is perpendicular to RT. Okay, so SA, RT, again, we are talking about the diagonals. Okay, the diagonals are perpendicular. Now, which of these parallelograms has diagonals that are perpendicular? Well, it's not a well, first of all, that's not true for every parallelogram, so we can get rid of that. And it's not true for a rectangle in general, so we can get rid of that. Okay, so we're down to either a rhombus or a square, okay? Because a rhombus will have perpendicular diagonals. So it's just a matter of, can we say for sure if this is a square or not? So we are told that RT is bigger than SA. So RT, which is this, I should change colors. Okay, RT is bigger than SA. All right, so the red one is bigger than the blue one. All right, so if the diagonals are not congruent, then we can definitely know that this is not a square. Even if they hadn't added in that last part, we already knew it was a rhombus, because that's the only one that had perpendicular diagonals. It was just a matter if it could be a square. So even if I didn't add on that last piece of information, we would have been stuck with rhombus. So once again, the answer should be rhombus. Okay. All right, number 5. Okay, quadrilateral SPAZ. So this is SPAZ. Now, segment PA is parallel to SZ. Okay, so PA is parallel to SZ. So we have parallel sides. A kite doesn't have any parallel sides, so we can throw out kite so far. Let's see, what else do we know? So far we have one pair of parallel sides, so that really could be anything else. Okay, PA is less than SZ. Huh, interesting. So we're talking about these bases. So PA is one length. I'll go ahead and put a single mark on it. SZ is another length. It's a bigger length, so I'll put a double mark on that. So these two opposite sides are not congruent. Well, guess what? If opposite sides are not congruent, then it's no kind of parallelogram. Parallelogram would have opposite sides that are congruent. So it's going to be some sort of a trapezoid. It's got one pair of parallel sides, and they are not the same size. Like that one is smaller, that one's supposed to be bigger. So it's either a trapezoid or an isosceles trapezoid. We are told that PZ is congruent to SA. So PZ, which would be like this, is congruent to SA, which would be like this. Okay, so we're told that the diagonals are congruent. Does that help us narrow it down between a trapezoid and an isosceles trapezoid? Yes, it does. Only an isosceles trapezoid will have congruent diagonals. So it must be an isosceles trapezoid. You know, of the remaining choices, it had to be an isosceles trapezoid. So the answer number 5 should be isosceles trapezoid. Okay, and last but not least, number 6. The perimeter of a kite is blah, blah, blah. Okay, I think this is supposed to be number 6. Okay, so number 6, quick check, yeah. The perimeter of a kite, PTSD, is 120. Okay, so PTSD. I should say that I don't really know. I mean, I say it's a kite, but I don't know which ones are congruent right now. I just know it's Kite. But anyway, PT is 3x plus 1. So let's say this is 3x plus 1. Okay? SD is 5x plus 3. So this over here is 5x plus 3. Because this is a kite, then I know that there's going to be consecutive sides that are the same. So if this is 3x plus 1, then there'll be another 3x plus 1 right next to it. All right, if this is 5x plus 3, then there'll be another 5x plus 3 right next to it. Okay, that's all I really know. Could PD have been the 3x plus 1? Like, do I know that the 3x plus 1 really goes there instead of here? No, I don't know. I could have put the 3x plus 1 over here. I don't know exactly how these letters go. But as far as finding x, it doesn't matter, because the point is that the perimeter is 120. Now, what does perimeter mean? Perimeter means if we add up all the sides, that's the perimeter. So, in other words, if I add up 5x plus 3 plus 5x plus 3 plus 3x plus 1 plus 3x plus 1, 3x plus 1. The sum of all these would be the perimeter. And the sum of all those should equal 120. Okay? So if I add up all my like terms, that's 10 and 6, so that's 16x. Okay, now that's 6 plus 2 is 8. So 16 plus 8 should equal 120. All right, the perimeter is 120. So it's just a matter of solving this equation. So of course, I'm just going to subtract 8 from both sides, like so. Now it's going to give me 16x is equal to, okay, 112. And then I need to divide both sides by 16. That will give me x equals 7. All right, so that's it. X has to be 7. Okay, and that is how you do it.